Three.
Hi, Nyla.
Okay. Not that we missed you today. All right. So let's take a look at today's lesson. We're going to talk more about proportional relationships. I told you guys the other day that we're going to talk quite a bit about proportional relationships. Today we're going to be looking at them in graphs and tables. So they ask you first to fill in the missing values. And so, Adela, you have a thought for us?
Yeah, so I think it's like times 7.
What's times?
Oh, like, for example, like 4 times, or like, it would be, if you do 4 times 7, it would be 28.
Okay. So this was 4 times 7. So how did you figure that out? Why 4?
I didn't count them.
I'm sorry?
I started from 2.
Yeah, but why 4? Why not 2 times 14? You know the answer to this. Why are you using 4 is my question. Oh, because 4 is over here. I'm sorry, I was asking a really easy question. Sometimes those confuse people. Yeah. So that means that each of them cost how much?
Each of them costs,
Or each, for each centimeter,
for each centimeter,
there's 7 pennies.
oh,
Because if for 4 centimeters, well, 6 times 4 is only 24.
I just counted wrong.
Okay. So now, if the height is 15, we can just do 15 times 7, which is 70 plus 35 is 105. What would we do to find the height if the number of pennies was 63? Yes, sir. Yeah, divide by 7. This would be 63 divided by 7 is 9 centimeters. Here where we do 3 times 7 is 21. And 12 times 7 is 84. So for part B, how many pennies are in a tower that has a height of 0 centimeters? 0. So it said add a row to the table that says this. All right, so now it wants us to put all these points on the graph, but we're going to need to scale this so that all the points in your table are visible on the graph. Okay, so if we do our horizontal axis as the height of the tower, yeah, please stop. So the height of the tower, gentlemen, okay, you don't have to be turned around though. In centimeters, what's the biggest height that I have? Try again? 15. All right. Well, I can just count by ones, can't I? So it's too much of a pain to put every single one of them on there. So what I'll typically do is something like this, so that you don't have to put every single one of them on there. Now, the biggest number of pennies I have is what? 105. How many squares do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So I've got 27 to play with. I'd like to make this, something relatively easy to work with. What do you think I should use for my scale for each individual one? 5? Well, if we did 5 and there were 27, 5 times 27 is 135. That'll work. So I'm going to mark that this one's 5, but then I'm only going to make a mark every 5 or so.
Wait, it starts at 5 and then it goes to 25?
This is 5, 10, 15, 20, 25.
And then it goes 25 to 30?
So this,
Are those?
sorry, I did that wrong. Thank you. So then 30 would be the next one. So it's 30, 35, 40, 45. This would be 50. Thank you. So this would be 75. This would be 100. And this would be 125, which gives us plenty of room. So up here, this is going to be my number of pennies. When you're doing graphs of real things, you should always label the axes. Axes being the plural of axis. So I know I'm going to go through 0, 0. Let's see, we go through 15, 105. So 15 is here. And that's 100, and this is 105. So I should be able to just connect those two, and all the other ones should be on there, shouldn't they? But let's see if they really are. So 4 is 28, 25, and that's 30, so 28 is right about there. And then 9, 63. 9 is here. That's 50, 55, 60, a little more than halfway up. Right about there. 3 is 21. So just barely above the 20. And we have 12 is 84. So that's 75, 80, not quite to 85. So does that look like that's going to make a line? Not really? I'm sorry?
Do we
Oh, I didn't put that one on there.
No.
Was that given? Oh yeah, 1.7. So I'm ever so slightly off here. That's pretty close. And even though we had kind of had to estimate, I'm pretty convinced that's a line.
If we were exact, it would make a line, but
Right.
it's hard to be exact.
It's hard to be accurate when you're having to estimate where those are in between. These corners are called lattice points, where the graph, the horizontal part and the vertical part intersect one another. If you're not graphing on the lattice points, it can be difficult to be super accurate. All right, let's go on to page 2. So what do you notice about the graph of height and the number of pennies? Two things. One is, when you're looking at the whole graph, is it straight or not?
It's pretty straight.
Looks straight to me. So what do we call that?
It's proportional.
The graph is a line. And secondly, the graph contains the origin. You guys know what the origin is, right? 0, 0. So when we were looking at Sonia's graph of birdseed weight and cost, well, was that graph a line? Yeah. Did it go through the origin? Yes. But it was a lot less steep than this line was. All right, let's go on. Casey loves cheese. And buys it whenever she can. Recently, she bought 5 pounds of mozzarella cheese for $15 and 3 pounds of Havarti for $7.50. Okay. Record in the tables and then plot and label points on the graph for Casey's cheese purchases. So let's see. For mozzarella, she bought 5 pounds. And that cost her $15. And for Havarti, 3 pounds cost her $7.50. What's probably the best thing to do right now before we go any further with those? Yes.
Divide the weight in pounds. Sorry, divide the cost by the weight in pounds to see how much it costs per pound.
Okay. So 1 pound dividing 15 by 5 is 3. And now we can find anything we want, right? That's called the unit rate. It's how much it costs for each pound. We can do the same thing here. 3 into 750 is what?
2.5.
Yeah, it's $2.50. So let's plot those. Yes?
For the cost per pound for the Hawaii tea, you put $2.50, so $2.25.
I'm sorry?
For the cost of no, never mind.
Okay. All right. So I'll do this in 2 different colors. If you've got colored pencils or something and want to do that, that's always fun. So the first one, 1 pound was $3. And 5 pounds was $15. All right, well, that looks pretty good. And then for the other one, 1 pound was $2.50. And 3 pounds was $7.50. So 5, 6, 7.50. Yeah, it doesn't like that. And I'm going to go ahead and do, let's see, if I bought 4 pounds, that would be $10. So I'm going to use that. To draw my line. Oh, hang on a second. Didn't have it in the right place. So it looks something like that. Yes.
One thing that you notice is that the mozzarella thing is slightly steeper than the Hawaii.
Right, because its unit cost is slightly more. Yeah. Mozzarella cheese has a unit cost of $3 per pound, whereas Havarti has a unit cost of $2.50. Are these both proportional though?
Yes.
Yeah. They're both lines. They both go through 0, 0. And if you doubled the number of pounds that you bought, you can expect to pay twice as much. All right, then for part B, it says, find another combination of pounds and cheese and the associated cost both for mozzarella and then another one for Havarti and plot those. All right, so if it was 2 pounds, how much is that going to cost for mozzarella? $6. So 2 pounds, $6. Hey, that's right there on that line, isn't it? And here, 2 pounds is going to cost you $5. 2 pounds, $5. Right there. Now, could we find other points? Yeah. I like the way this question is asked. It makes me laugh. It says, can you find any other points that should be on the graph? I'm like, should be? That seems like a value judgment to me. Are there other ones that could be? Yeah. So like here, that I figured out that it was $4, for 4 pounds was $10. Let's see, so 5 would be $12.50. So 5 is 10, 11, 12.50. And 6 would be 15. So I'm going to extend this line. And then let's see, 3 pounds here would be $9. What's the easiest way to find 4, everybody?
2 times
3 times
6 times 2. Thank you, sir. Be 12. And then 6 would be double the 9, so that's 18. I want to point something out to you that we're going to use quite a bit later on in the year. I want you to notice that from 1 pound to 2 pound for the mozzarella, if I go to the right 1 space, and that is 1 pound, right? How many dollars did I go up? I feel like not everybody's with me at the moment. 3. And isn't that my unit rate? This is one of the ways you can get the unit rate by looking at the graph. If I move to the right 1 unit, and this is 1 unit, it's not 1 space, but it is 1 unit, how much do I go up?
About 2.5.
About 2.5. Okay, that's a way you can see unit rate on a graph. Move to the right 1 space and see how much it moves up, or it could move down. Okay, but not if it's proportional.
Well, I mean, it could move down if it's a proportional relationship of going down.
But if it's a proportional relationship, where does it have to start?
At 0, 0.
Right, so it'd have to be down here in the 4th quadrant someplace. Yes, ma'am. Yeah. Got it? All right, so how do the graphs for these types of cheese compare? They're both lines. Oops, I pressed that stupid button on this pen. They're both lines that contain the origin. And as Sam pointed out, you can tell which one is more expensive by looking at which one is steeper. And we've already talked about the unit rate. I want to real quickly, right before the bell rings here, please stay seated. Which one of these shows a proportional relationship? So I want you to notice on this one, when we double the x, does the y double here? Does that make it proportional? Yes. Hang on. Sit still. Don't put your stuff away yet. I'll wait until you get it back out. On this one, when the x doubles, does the y double? No, this is not proportional. All right. Y'all have a great weekend. I'll see you at the pep rally.